Hello everyone. Now we are going to see the numerical problems on work or energy. So first of all, we will see some MCQs, and you can read the question number 1 here. The energy is released in some nuclear reactions, and which nuclear reaction takes place in a nuclear power station, and which nuclear reaction takes place in the sun. So we know that the nuclear reactions are of two types. The first is a nuclear fission, and the second one is called as nuclear fusion. So fusion is a kind of nuclear reaction where the lighter nuclei combine and they form the heavier nucleus, and the fission is the one where the heavier nucleus split and it forms the lighter nuclei. So in the nuclear power station, what kind of reaction takes place? That reaction is nothing but the nuclear fission. Okay? This kind of reaction takes place in the nuclear power station, and in the sun nuclear fusion reaction basically takes place. Okay, so where in the sun the hydrogen atoms they combine to form the uh, helium atom, and in the nuclear power station we know that we are using the uranium, and we are going to do the nuclear fission using the neutron bombarding, and then we are getting some lighter nuclei. Okay, the nuclear reaction you will be learning more in detail in the nuclear block, but for time being just note that in the nuclear power station the fission is there, and in the sun or in all stars nuclear fission is there. So answer, the B option is the answer. The force acts on, the second question, acts on an object and causes the object to move a certain distance in some direction as the force. Okay, so which row represents the situation in which the largest amount of force? So here we want to calculate the largest amount of force, sorry, the largest amount of work is done on the object by the force. So here we need to find out the largest amount of the work. So we know the work is nothing but the force multiplied by the distance in the direction of the force. So it is already given the same direction the distance has as that of the force. So we need to just multiply the things, and by multiplication we can understand which is the highest. So 2, because it force into distance, nothing else. So 2 into 40, the first one will get about 81, and here 10 into 2, so we'll get here 20. The third one 20 into 6, so we'll get here 120, and the third one we can see here 100 into 1, so we'll get 100. So which is the largest value? So 120 is the largest value, so option number C is the answer. Now the question number 3 here, an object initially at rest is dropped from the height of 12 meter. The change in the gravitational potential energy when it falls to the ground, it's 565 joule, and the frictional forces are negligible, so we are not counting the frictional force. And what is the speed when it hits the ground? So here you can see the scenario. I have attached one image over here. So this object is falling down, so when it is at some particular height, it has only the potential energy, because here at this height the velocity is 0, so kinetic energy is also 0. While falling down, the kinetic energy increases and the potential energy decreases, and when it reaches the ground it has all the kinetic energy, and if I consider the this negligible air resistance, then potential energy will be 0. So this will come out to be 0, because height h will be 0 at the ground, so entire energy will be the kinetic energy. So we are just going to equate, because entire potential energy is converted into the kinetic energy. So I can say the kinetic energy, that is half mv square, will be equal to mgh. Okay, so mgh is nothing but potential energy. So here the potential energy is converted into the kinetic energy, and so those are equal, so we can here cancel m and m here. G value, we know the G value is nothing but, you can take 10. H height is given, that is nothing but 12 meter, so you can put this H is equal to 20 meter, and you can calculate. This is 10, you can consider for G, multiplied by height is 12, that is nothing but half into V square. So no need of mass is cancelled out here, and we can calculate V square. You can make the V square as a subject, and then you can make the V as a subject, and if you calculate value, it will come close to the value of 15.5 meter by second. So answer number B is the option. B is the answer. You have to just make V as a subject and you can calculate. Now the question number 4. Which energy resource does not derive its energy from the sun? So we know the sun is the supreme source of energy, and it actually gives the energy and that converts into different forms. But here in the options, the hydroelectric, nuclear fission, waves and wind, only the nuclear fission is the one which does not derive its energy from the sun, because it's the nuclear energy and that is coming from the mass of the nucleus itself. So we know that in the nuclear fission the splitting of the nucleus occurs and it does not require any external energy because it is a nuclear phenomenon. And waves are the result of the energy coming from sun. Wind is also the result coming from the sun's heat. So all these are not options. So option number B is only the option which does not derive its energy from the sun. Now the last question, you can see here the diagram represents the energy transfer for a device. So this is our input energy, and some amount of energy is a useful energy and remaining amount of energy will be wasted. And redrive has a 50% efficiency. So what equation is correct? Which equation is correct? So 50% efficiency, so efficiency I have written over here. Efficiency is useful energy and the useful energy output divided by energy input, and you have to multiply 100 to get the percentage here. So here 50% is device efficient, that means 50% you are getting as a useful output and remaining 50% will be wasted. Remaining 50% will be the wasted one. So that means useful output energy must be equal to wasted output energy divided by 2. Okay. So you can see from here also the efficiency is 50%. So 50% is nothing but that is equal to 0.5, and 0.5 is nothing but 1 by 2. So I can write down here 1 by 2. So 1 by 2 is equal to useful energy output divided by the energy input. So we can say that useful energy output is nothing but wasted output energy divided by 2. So option number B is the correct one. So here you are just simply using the efficiency formula and nothing else. So we are going to end our MCQs here, and now we will see the structure problems. So now we will see the first question in the structure problem. So you can see here this figure 2.1 shows a conveyor belt transporting a package to the raised platform, and the belt is driven by the motor. So here you can see the package is kept over the belt, and this is a motor and it is continuously rotating, and so that the package will be going to the this platform, raised platform. The mass of the package is given, that is a 36 kg. Calculate the increase in the gravitational potential energy of the package when it is raised to the vertical height of 2.4 meter. So this vertical height, right, it is starting from this point and it is going to this point, and the vertical height, this vertical height, basically that height is given, that is 2.4 meter. So we want to calculate the increase in the gravitational potential energy, and we know what is the formula for the gravitational potential energy. All the formula I have written over here, the potential energy, kinetic energy, work and the power, etc. So the gravitational potential energy is nothing but, we know that formula is nothing but mgh, and here the value of the mass is given, that is nothing but 36 kg. So multiplied by g value, we take 10 for your simplification. Height, that is 2.4, it is already given. So we are getting roughly the value over here is nothing but around 864 joule. 864 joule value is coming out to. So 2 or 3 significant figures are okay. So 864 Joule I will write down here again, so that you will get the 4 marks. If you forget, write down over here, so unnecessarily it will in the 1 mark. Okay, so this is the first question, that is very easy. We are going to just apply this formula. Potential, gravitational potential energy is mgh. So remember, always we take the vertical height, not the slanting height for the this mgh formula. Calculate the now they here the question B here, the package is raised through the vertical height of 2.4 meter in 4.4 seconds. Here additionally the time is also given. Calculate the power needed to raise the package. So we are going to use the work power formula. Power is nothing but this work by time or the energy by time. So I will write down over here. So power is nothing but equal to energy divided by time. So we know that the gravitational potential energy we are going to consider here. So gravitational potential energy that we already calculated, that is nothing but 864. So here 864 divided by time taken is given, that is 4.4 seconds. So 4.4, and we are getting the value of the power is nothing but around 196 watt. So we know the unit for the power is watt, so I will write down here 194 watt. So this is another simple problem. We can say firstly we'll calculate the gravitational potential energy. Here we calculated the power. Now the C question is this: the electrical power supply to the motor is much greater than the answer in B. Okay, so here we calculated the value of around 194 watt, but the actual power given is much greater than this answer given in the B. They explain how the principle of conservation of energy is applied to the system. So see here what happens when the conveyor belt is going from here to here, and if you are going to supply this much power, within this much time it is expected it will go up, but what is happening, we are going to apply more power, and still how the principle of conservation of energy is taking place. So it is actually always it is taking place, but practically some amount of energy is always converted into some other form of the energy. So principle of conservation of energy is always there. So we can write down here some energy that we are going to provide at the beginning is dissipated into the surrounding okay, or you can write down in the form of heat, namely in the form of the heat, and some energy is dissipated, but it does not mean the total energy conservation is not there, but we can write down the total initial energy is always equal to final energy. Okay, so the energy conservation law is always there. Okay, you can write down either in the word or expression, any way you can write down, but the total energy is always there, but some amount of energy is dissipated into the surrounding in the form of the heat. Okay, there are other forms of energy as well, like sound, friction, etc, etc, but the main is the heat, and you have to write down always the heat, or can write down the thermal energy. Okay, that is the most important keyword to get the 2 marks for this question. Now last question is that assume that the power here available to raise the package is a constant. So we are assuming the power is a constant here, and the package of the mass greater than 36 kg is raised through the height, and suggest and explain the effect of this increase in the mass. So we are going to increase the mass, so what operation on the operation of the conveyor belt. So what is the impact and what is the operation of the conveyor belt? So we are going to increase this package mass, and power is constant. So power of the motor is constant, only the package is more. So what would be the output, what would be the impact or the effect on the conveyor belt? So first of all I will write down here so power formula, we know that is nothing but energy divided by time. So we know that energy divided by time here, it is the first important thing. And as can write as the mass increases the gravitational potential energy. I write down gravitational potential energy also increases. Okay, as the mass increases, the gravitational potential energy, you can say that is also greater, and there will be the increase in the gravitational potential energy, because here E is nothing but mgh. So if you increase the mass, of course there will be the greater potential gravitational potential energy. And as the P is constant, you can say as the P is constant here, so if I take P constant, energy will be directly proportional to the time here. Okay, so energy will be directly proportional to the time here. And so we can say here, more amount of work is to be done, more amount of work needed to raise to same height, because energy is nothing but the work and energy is directly proportional to T. So more amount of energy is needed, more amount of work is needed to go to the same height. And as the power is constant, we can say the time will be more, time taken will be longer. So time taken to reach the height will be longer. Okay, so here the P is constant, and as I will show it over here again, so P will be equal to, here P will be equal to energy divided by time. And as the P is constant, this is constant, so I can write down T will be coming to the left hand side, so T will be directly proportional to E, and E is nothing but mgh here, E is nothing but mgh. So if M is increased, the mgh will increase, that means T will increase, that means the time taken will be increased. That's why I have written over here. So as the P is constant, more amount of work is needed to raise the height. More amount of work means more amount of energy. Okay, that is nothing but more amount of work. So energy is more, that means time taken will be again more, because time and energy are proportional to each other, because power is a constant. So this way you can write down the answer to get all the 3 marks. Okay. So now we are going to the next question. Here the second problem, you can see the electric train is initially at rest at the railway station. The motor causes a constant force of this force is given over here 360,000 Newton to act on this train, and the train begins to move. To state the form of energy that is gained by the train and begins to move. So which energy is gained by the train? As the train is moving, that means it is having some motion, velocity, and whenever there is a velocity, we know the kinetic energy, because it is nothing but half into mass into velocity square. So we can write down here the kinetic energy. The train gains the kinetic energy as it starts moving. Now the B part here, the train travels a distance of 4 kilometers along the, here you can see the straight horizontal track. We calculate the work done on the train during this part of the journey. So how we are going to calculate the work done? So work done formula is already given over here. So we have given all the formula here. The work done is force multiplied by distance. The distance is given here 4 kilometers. We have to convert that into the meter, and the force is already given, that is 360,000. So that we can write down. So we can write down here the formula for the work. So work is nothing but the force multiplied by the distance, and the work we have already given provided with the value, that is 360,000, that we can write down as 3.6 multiplied by 10 raised to 5. So this way we can write down 10 raised to 5, and the distance given is, that is nothing but 4 kilometers, that I can write down 4,000 meter. So because everything will be the SI system unit, so if you calculate this value, that 3.6 into 10 raised to 5 multiplied by 4,000, that will come out to be around 1.4 multiplied by 10 raised to 9. So this is the value we are getting over here for the work. And the unit of the work is joule. We have to write down over here. The same value I will be writing down over here, so that will be 1.4 multiplied by 10 raised to 9 joule. So this value will be this. Now the second sub question here, you can see the mass of the train is 450,000 kg, that is 4.5 into 10 raised to 5 kg, and calculate the maximum possible speed of the train at the end of the first 4 km of the journey. So we are asked to find out the maximum speed. For that we are using the formula for the kinetic energy, and since the work done and the kinetic energy are interconvertible, and we can equate the kinetic energy with the work done. So work done we have already calculated, that is 4.5 into 10 raised to 9 joule. That should be equal to the kinetic energy. The kinetic energy is half into mass into v square, and we can equate them to calculate the value of the maximum speed. So we can equate them to calculate the value of the maximum speed here. So I will write down the work done will be equal to half into m into v square, and that is nothing but this. So the v square, we can write down the v square will be equal to if you make the v square as a subject here, and then you can find out it will be the work done. It will be nothing but the work done, this multiplied by 2 divided by the mass. So this is the, if you make the v square as a subject, you will get 2 multiplied by the work done divided by the mass of the train. So here you can write down the work done is already, we know the work done value is nothing but 1.4 multiplied by 10 raised to 9 here. This is the value of the work done that we already calculated, multiplied by 2 divided by the mass, that is 4.5, and write down 4.5 into 10 raised to 5 here. So this value is nothing but this, and if you calculate this entire value, then you will get all this thing. So if you calculate this value will be coming close to the around 6400. So that value is nothing but v square. So if you make the square root of this, so if you make the square root of this is nothing but v square. So if you make the square root of this both side, v square will be v, and 6400 will be 80. So 80 meter by second. Meter by second is the unit for velocity, so maximum speed will be 80 meter by second. So we'll write down over here again. So 80 meter by second will be the maximum speed. So we have just equated work done is equal to kinetic energy, then v square as a subject, and then we can calculate this 6400 will be v square. So taking the square root on both the sides, will get the value of v will be 80 meter by second. Now in practice, the third sub question, the speed of the train is much less than the value calculated in this 2. Okay, so here 80 meter by second, it is not exactly this, but such is one reason why this is the case. And we know that as I already told you, the some energy is always dissipated in heat energy or any other energy, and work is always done by the friction as well. And the speed, you can say, due to the, and write down, due to the work done against the friction, work done against the friction, the speed is actually less because there is a friction, and work is done by the friction as well, which reduces the speed. Or you can also write down some energy is converted into the thermal energy as well. That is also okay with this question. The last one, the after traveling 4 km, the train reaches the maximum speed. Here it continues at this constant speed on the next section of the track, where the track follows a curved path. So here after that, the track follows the curved path here, which is a part of the circle here, and state the direction of the resultant force on the train as it following the curved path. So we know that whenever we have the curved kind of path, and which is a part of the any circle, the force acting is always toward the the center. Force acting on the object is always toward the center of the circle of that curved path, that is nothing but called as the centripetal force. So we can write down the direction of the force, direction of the resultant force is always, you can say, the perpendicular to the curved path, or you can say towards the center of the circle. We know that that is nothing but the centripetal force. Any object is moving in a circular path, we know this force acting is the centripetal force always toward the center of the circle. So let's go to the next question. Now the question number 3 here, the boxes on the left contains the names of the some sources of energy. So here you can see some sources of energy are here. The boxes on the right contains some properties of the sources of energy. So here are some properties given. Draw two straight lines from each box on the left to the boxes on the right, which describe the source of energy. Okay, so we have to just draw the line here. Here the solar energy is here, the natural gas is there, and you can see here the properties are given, like renewable, non-renewable, polluting, and the non-polluting. So we know the solar energy, we had seen the solar energy is a renewable kind of energy, and the solar energy is nothing but, can say, it is a renewable energy. First of all, that is the one thing we had seen before, and the second thing we had seen, it is basically the polluting, because it uh, basically contains toxic materials. That is nothing but the polluting part of the solar energy. So natural gas, we can see natural gas is a non-renewable kind of energy source, and the natural gas is what kind of thing is this? It is again the polluting thing. Okay, both are polluting thing. So, but one of them is a renewable, one of them is a not renewable. So that this is the way we can do for the first question A here. Now this B question is a coal fire power station of polluting, and state the advantage of using the coal as the source of the energy. Though it is polluting, there are some advantages and disadvantages we have seen. What are the advantages? The advantages is that it is relatively, you can say, it is relatively cheap, and another one important thing, we can also write down one more point here, it's widely available. It's very easy to have the availability of such kind of coal fire station, and that's why it is reliable in that sense. Availability means what? It is a reliable kind of source, and it's relatively cheap. It's not that cheap, but only relative comparison it is a cheap that way. The C part here, the coal fire power station generates electricity at the night when it is not needed. Some of this energy is stored by pumping water to the amount to a mountain lake here. Then when there is a high demand of the electricity, the water is allowed to flow back through the turbines to generate the electricity. We had seen all the flow, like how the water is stored, is coming down, converts that energy, potential energy, into the kinetic energy, then that runs the turbine, and turbine runs the generator, and that generate the electricity, etc. On one occasion, you can see this much, 2.05 into 10 to 8 kg of water is pumped up through a vertical height of 500 meter. Here calculate weight of the water. So weight of the water is a very simple thing. Weight of the water, we can directly find out. Weight is nothing but mass into the gravity, and we know that mass of the water is already given, that is 2.05 multiplied by 10 raised to 8. 10 raised to 8 is given already here, so this weight is very simple. Into the gravity, we can say it is 10, so we have to just multiply this number with 10 here, then acceleration to gravity, and we are getting the value of 2.05 multiplied by just 1 power more, so 10 raised to 9. This is the way we are going to have this, and the Newton is the nothing but the unit of that weight, so it is nothing but the type of the power, nothing else. So here I will write down here that thing again, 2.05 multiplied by 10 raised to 9, so that is nothing but Newton, and this is the way we can answer the A part. Now the next question is this: the calculate the gravitational potential energy needed gained by the water. So we know the gravitational potential energy formula is already given here. mgh here, the same mass is pumped through the vertical height of 500 meters. So height is also given. We can write down the gravitational potential energy. Gravitational potential energy is nothing but, we know that is nothing but mgh here, and mg value we have already calculated above. That value we already know, that is nothing but 2.05 multiplied by 10 to 9. The mg value we already know over here, and the remaining value is nothing but the value of the height, that is nothing but here 500 meter. So nothing but the 500 meter. If you calculate this 2.05 into 10 to 9 multiplied by 500, you will get the value of around 1.03 into 10 to 12. This value you will get. That unit is nothing but joule. The energy unit is nothing but the joule one. Okay, that everybody knows that energy unit is nothing but joule. So I will write down over here 1.03 multiplied by 10 to 12 joule. Once again over here, and this is nothing but our final answer, energy gained. Now the electrical energy used to pump the water up to the mountain lake is 1.2 into 10 to 12 joule, and only 6.2 into 10 to 11 joule of energy generated when the water is released. So this much energy, you can see this much is supplied here, and this much is energy is only the used. So calculate the efficiency. We know the efficiency formula: useful energy output divided by the energy input multiplied by the 100. So we have to just do this ratio here. So we have to note down this formula, and after you put this formula, then you will be putting the values here. I am putting the values directly here. So efficiency is equal to, you have to put this formula. So that formula is written over here already: useful energy output divided by energy input, that you have to put, and then I'm putting the values directly. That is 6.2 multiplied by 10 raised to 11, that is given over here, the energy which is actually being used, and then this energy divided by the energy input, that is 1.2 multiplied by 10 raised to 12. Okay, this is the energy which is provided. So that is nothing but in the, can say, in the denominator, and this ratio, if you calculate simply in your calculator, you can get the value of this value will be just the ratio, and that ratio here also you can multiply this thing the 100%. So here I will put in the bracket here, or doesn't matter if you put bracket or not, but just for understanding or simplification, I'm putting the bracket over here, multiplied by 100%. So 100% will be this, and if you calculate this ratio multiplied by 100, you will get something like 52%. Whether you put the values of percentage or not doesn't matter. If you don't put the value of 100%, you will get, it is something but 0.52. so you will get here 0.52. if you multiply it by 100 and putting the percentage sign, you will get 52%. So it doesn't matter if you put or not, that is your choice. So here I am going to write down here the 52% again. So this is the part C, or question third sub question in the question 3. So here we are going to end our descriptive or structured problems for work power energy. Thank you so much.